Welcome to my video lecture on circuit theory. Today's topic is based on independent and dependent sources and source transformation technique. Myself, Rumon Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrasekhar BBA Engineering College. In this topic, we will discuss about various sources. Mainly, we know that there are mainly two types of sources. One is voltage source, another one is current source. And these two types of sources can be different type. That means it can be independent source. Independent means it's not dependent with any other parameters. And it can be dependent source where it will be dependent with other parameters. And then source transformation technique. Source transformation technique means when voltage source and current source they are transferred with each other. There are some certain conditions, certain rules are there in this case, and we can add the things by using source transformation technique. So how this can be possible, that part we will see in this lecture. So here mainly there are types of sources. Our first point is on types of electrical energy sources. Energy sources are defined as a device that generates electrical energy. The device that electrical energy, that is basically energy source. So energy source can be DC energy source, can be AC energy source. DC energy source can be generated from DC generator, battery, AC generator, AC sources, or it can be also trained as alternators. Alternators can generate AC sources. Now, they can be classified according to the current voltage characteristics, and that nature is shown here. Electrical energy dependent into two parts, independent source and dependent source. Independent sources are again two types. One is voltage source, another one is current source. Then dependent source can be again four types. Voltage controlled current source, or it can be said voltage dependent current source. Second one, voltage controlled voltage source or voltage dependent voltage source. Third one, current controlled current source or current dependent current source. And fourth one, current controlled voltage source. These are the main four types, that means of dependent sources. Dependent source, voltage dependent voltage source, voltage dependent current source, current dependent voltage source, and current dependent current source. These are the main four types of dependent sources. Now, first we will start with independent source. Independent source, that means an ideal voltage source, and that ideal voltage source have some following features. First one, it is a voltage generator whose output voltage remains absolutely constant whatever be the value of output current. That means output voltage is constant, it is not dependent with any other parameters. Whatever may be the output current, the voltage is always fixed. So it is independent. Second one, it has zero internal resistance. Second one, it has zero internal resistance, so that voltage drop in the source is zero. That means there is no internal resistance. We know if there is some internal resistance, there will be voltage drop. So in case of ideal voltage source, we are assuming there is no internal resistance, so there is no voltage drop. Third one, the power drawn by the source is zero. That means the source has no power drawn. That means the power drawn from the source is zero. But in practical, this is not possible. Definitely in practical source, there will be some internal resistance and there will be some voltage drop. So that characteristics is shown here. This is example of independent source ideal case, and this is independent source with practical case. In ideal case, we are assuming that fixed amount of voltage is there generated, there is no voltage drop, but in practical there will be some drop, so the characteristics is falling like that. In practice, the output current does not remain constant but decrease with increase in voltage. That I have already said. In practical case, there will be some internal resistance, so there will be some drop, so there will be some decrease. So practical current source is represented by an ideal current source in parallel with high resistance. In parallel with high resistance, and the output current becomes I1t equals to IT minus Vt by R. Similar to the voltage source, an ideal current source is not practically possible. No current source can maintain constant current, but even when its terminals are open circuited, the output current of a practical current source decreases as the output voltage increases. The VI characteristics of ideal and practical sources are already shown in the previous picture, this one. This is the VI characteristics of ideal source and practical source comparison. In solar cell, which can produce constant current with a specific range of output voltage, is an example of independent current source. Independent current source is example solar cell. A natural lightning can be considered to be an ideal current source. That means the lightning, whatever amount of current is created, that can be also an example of ideal current source. When a natural lightning strikes the top of a conductor, the resistance to the ground path is ideally zero. But when the lightning strikes a non-conducting element like a top of a tree, a large voltage is developed across the element, which is flushed out immediately because it will create a potential difference, so a huge amount of voltage is generated, and due to that the element is flushed out immediately because of that high voltage. Next one is dependent source. Independent sources, also referred as control sources. Control sources means it is dependent with some other parameters. The source voltage of current is not fixed but is dependent on voltage of current at some other location in the circuit. Thus, there are four types of dependent source. One is voltage controlled voltage source. Second was current controlled voltage source. Third one voltage controlled current source. And fourth one current controlled current source. These are the diagrams, or we can say that this is the symbols of voltage controlled voltage source. See here, it is dependent on some voltage. So K is the fixed or magnitude value and Vx is the voltage through which it is dependent. Second one is current controlled voltage source. So it is dependent on some other current source. So it has been showing as K2Ix. That means Ix is the parameter which it is dependent. Third one is voltage current controlled current source. That means it is dependent with some other voltage, that is Vx. So Vx is the voltage which it is dependent. Fourth one is current controlled current source. That means it is dependent on some other current source. So that current source is Ix. So these are the symbols of the dependent sources present here. Next technique is source transformation. Transformation means we will interchange. That means voltage source will be interchanged in form of current source, or current source will be interchanged in form of voltage source, or it can be combination of series parallel, of resistance that can be changed to parallel connection series. In that way, some rules are there that we will highlight in this portion. Transformation of voltage or current sources into a single voltage or current source and voltage source into current source or vice versa is known as source transformation. This makes circuit analysis much more easier. Using the source transformation technique, it is very much easier for us to simplify a given complex network. So first rule is our rule 1, where several voltage sources V1, V2 up to Vn, if connected in series, can be replaced by a single voltage source V, which is summation of V1 plus V2 plus V3 dot Vn. That means if multiple voltage sources are present in series, we can sum those voltage sources to a single voltage source. Suppose we have 3 voltage sources, 2 volt, 3 volt, 5 volt. Then we can write it as 5, 3, 8, 8 and 2, 10. That means we can write it or replace it as 10 volt source of a single voltage. That means if several voltages are connected together in series, we can add those up. Right? That practical example I can give. Suppose we are using a torch, and in torch we are putting 2 5-volt batteries. That means 2 5-volt batteries, we are putting those batteries plus minus. That means those are connected in series. That means we are giving 10 volt supply to the torch. That means that connection is a series connection and total 10 volt is active. Next, rule 2. A number of voltage sources connected in parallel will result a single voltage source of same meaning. That means a number of voltage source V1, V2 up to Vn, if it is connected in parallel, then it means same voltage source. That means V1, V2, V3, those are equal. Okay. Therefore, voltage sources should not be connected in parallel unless they have ideal potential. That means different amount of voltage sources cannot be put in parallel. If we want to put voltage sources in parallel, that means same voltage source we have to put. Otherwise, it is not possible. Another part, that is a number of current source I1, I2, I3 putting in series will result a single current source, that is I1 equals to I2 equals to IN. That means different current source if put in series, it means same. And similar way, if different current sources are put in parallel like this, that means we can replace it to a single current source, which value will be equal to summation of this all. That means suppose this is a 2 ampere current, this is 2 ampere, this is 3 ampere and this is 5 ampere. These three current sources are connected in parallel. Then we can replace it into a single current source of 5 plus 3 plus 2, that means 10 ampere. Okay. In that way, we can also summarize. Rule 3. As far as the computation in the remainder of the networks are connected, a resistor in parallel with an ideal voltage source and a resistor in series with an ideal current source may be ignored. That means a resistor with voltage source in parallel or a resistor in current source with series, this can be ignored. That means a voltage source with resistor we can consider with a simple voltage source. And similar way, a current switch with resistor we can similarly ignore the resistance and we can consider the single current source. Rule 4. A voltage source Vt in series with a resistor R can be converted into a current source It in parallel with the same resistor R, where It equals to Vt by R. Similarly, a voltage source Vt in series with capacitor C may be converted into a current source It in parallel with C, where It equals to C dVt dt, and a voltage source Vt in series with inductor L may be converted to current source It in parallel with L, where It equals to 1 by L integration Vt dt. This is another example. Here a voltage source is connected with a series resistance. Now this form we can transform it to current source. That means this voltage source can be converted to current source, where the value of current source will be V by R, and this resistance which is connected in series with the voltage source, that will be replaced in parallel part like this. Okay. So in that way we can convert the voltage source into current source, or vice versa. Suppose we have current source parallel with resistance, then we can convert it into voltage source with series resistance, where voltage source value will be the value of I current source multiplied with R, that will be the value of voltage source, and that resistance will be replaced in series. Okay. In that way we can also convert this voltage source to current source or current source to voltage source. That's all about our source transformation technique and independent and dependent sources. Various problems related to this we will solve in our later lectures. Thank you for listening my lecture.